Good evening. How are y'all doing? All my millions of watchers and viewers. uh, tonight's low key. It's 8:40. I will probably stream for an hour. So I'm not going to start on anything that's going to turn into a up till 2 a.m. fiasco. So I decided I would start looking at this book I bought called, let's see, the book is called Building a Large Language Model is the name of the book. This was recommended on, was it Tim? It was either the Tim Ferriss podcast or I think it was the Tim Ferriss podcast, but I think it was because Lex, if you know who Lex Friedman is, he had mentioned this book at some point. I can't remember if it was on Tim Ferriss's podcast or his own podcast, but that's where I've found the book. And so I bought it, and I've had it now for like a week, and I haven't cracked it open. So tonight's the night we're going to crack it open for about an hour. And if you stop in, we can chat too if you want, but otherwise I'm going to be learning about building LLMs. Let's see. Large language models such as those offered in OpenAI's ChatGPT are deep neural network models that have been developed over the past few years. They've ushered... Oh, actually, let me also open up... I like to use Obsidian to take notes. Let's see, new note. The book is called, what is the book called again? Build a Large Language Model. Let's see. Book on Amazon. How do I normally do this? I have kind of a format that I like to follow. There you go. Yeah, book on Amazon. Book on Amazon. I know not everybody likes to take notes when they read, but I do. Even if I don't reference them a lot, I feel like it's helpful to still take the notes. Sebastian Rachak. I honestly don't know if I'm saying his name right. Rachak. I feel terrible when I can't figure out if I've said someone's name right. Sebastian Rachak. This must be his LinkedIn. I'll bet he is in high demand these days, having written a book on LLMs. Okay, back to the book. Maybe sometime we can do a video or a stream going over my notes, how I take notes, and how I organize stuff. That seems to be a very popular thing on YouTube. Chapter 1. Okay. Large language models, such as those offered in OpenAI's ChatGPT, are deep neural network models that have been developed over the past few years. So, LLMs equal deep neural network model. That should be LLM. Large language models. But probably not all, but this is probably not true. Deep neural network does not equal large language models. I mean, all LLMs are deep neural networks, but not all deep neural networks are LLMs? That's a question I have. They ushered in a new era for natural language processing. Before the advent of LLMs, traditional methods excelled at categorization of tasks such as email spam classification, straightforward pattern recognition that could be captured with handcrafted rules or simpler models. However, they typically underperformed in language tasks that demanded complex understanding and generation abilities, such as parsing detailed instructions, conducting contextual analysis, creating coherent and contextually appropriate original text. For example, previous generations of language models could not write an email from a list of keywords, a task that is trivial for contemporary LLMs. LLMs have remarkable capabilities to understand, generate, and interpret human language. However, it's important to clarify that when we say large language models understand, we mean that they can process and generate text in ways that appear coherent, contextually relevant, but they possess not that they possess human-like consciousness or behavior. This is something that a lot of people need to commit to memory. Copying and pasting from a PDF's weird, huh? It's so weird that when I stream from my computer, absolutely nobody shows up. But if I stream from my phone, today I had like 22 concurrent viewers. It's crazy. It's so weird that way that works. I wonder if it warrants me setting up a vertical stream from my computer and trying that and seeing if vertical streaming is just served more to more people. Let's see. Enabled by advancements in deep learning, which is a subset of machine learning and artificial intelligence, in artificial intelligence focused neural networks, LLMs are trained on vast quantities of text data. So, deep learning is a subset of machine learning. This is an area that I have done very little study in. So this is all the words, the vocabulary, all of it's new to me. But this is the level of the stack I wanted to go to. Like, I've built several things that use LLMs through, foundation models like ChatGPT, like Gemini. But I want to go one layer deeper, right? And that's the whole reason for going through this book and reading this book, is I want to understand a layer down the stack. So let's see. This large-scale training allows LLMs to capture deeper contextual information and subtleties of human language compared to previous approaches. As a result, LLMs have significantly improved performance in a wide range of NLP tasks. Text translation, sentiment analysis, question answering, and many more. Other important distinctions between contemporary LLMs and earlier NLP models is that earlier NLP models were typically designed for specific tasks such as text, categorization, language translation, etc. So they were kind of like purpose built, is what he's trying to say. They were like purpose built for those things. So you need like a model for each of those use cases. While those earlier excelled in this narrow applications, LLMs demonstrate a broader proficiency across a wide range of NLP tasks. The success behind LLMs can be attributed to the transformer architecture that underpins LLMs and the vast amount of data which LLMs are trained, allowing them to capture a wide variety of linguistic nuances, context patterns that would be challenging to encode manually. So, he said, the success behind LLMs can be attributed to the transformer architecture that underpins many LLMs. So that's I think that's very important. So we need to know more about what the transformer architecture. We need to know more about that transformer architecture. I heard somebody describe LLMs as like a lossy compression, which I think is a good mental model, right? It's like taking huge amounts of data, compressing it with some loss, but still good enough that you can extract out the main points of the data that was put in. So I thought was kind of an interesting way to think about it. Okay, another important distinction. No, we're beyond that. We're down here. This shift towards implementing models based on transformer architecture and using large training data sets to train LLMs has fundamentally transformed NLP, providing more capable tools for understanding and interacting with human language. The following discussion sets a foundation to accomplish the primary objective of this book, understanding LLMs by implementing a ChatGPT-like LLM based on the transformer architecture step by step in code. This is what I'm most excited to do. That's what I'm most interested to take away from this book. So what is an LLM? An LLM is a neural network designed to understand, generate, and respond to human-like text. These models are deep neural networks trained on massive amounts of text data, sometimes encompassing large portions of the entire publicly available text on the internet. And we also know some not publicly available text, as the New York Times is showing us. There's actually a lawsuit. I don't even know the status of it. The New York Times OpenAI lawsuit. Yeah, so I'll be very interested to see if OpenAI loses that lawsuit. That could be a really big deal. Like imagine a world where LLM companies, or people who build foundation models. Okay, so imagine a world where people who build foundation models are like Spotify, and they have to pay a cut to, in this case, not the music industry or the record labels, but they have to pay a cut to the originator of the content that their models are trained on. That would be wild. Wild, particularly for the people who generate the content, right? That could be like a real meaningful way of earning a living, is producing content that people use to train LLMs. That'd be pretty wild. Okay, so back to the actual focus, Stephen. Focus. Let's see. Yep. The large language model refers to both the model's size in terms of parameters and the immense data set on which it's trained. Models like this often have tens or even hundreds of billions of parameters, which are the adjustable weights in the network that are optimized during training to predict the next word in a sentence. Okay, there was a lot there. Models like this often have tens. So we have parameters, right? So model parameters are the adjustable weights in the network that are optimized during training to predict the next word in a sequence. Okay. So I understand like the definition there, but I don't understand what the weights in the network. What does that mean? Hopefully we'll find out. Next word prediction is sensible because it harnesses the inherent sequential nature of language to train models on understanding context, structure, and relationships within text. yet it is a very simple task, and so it is surprising to many researchers that it can produce such capable models. In later chapters, we will discuss and implement the next word training procedure step by step. Okay, sweet. That's exciting. Also, I do realize that every single one of these pages has my email on it. It's not a big deal. My email's pretty publicly available in a lot of places, and nobody ever sends me anything. So LLMs utilize an architecture called the transformer, which allows them to pay selective attention to different parts of the input when making predictions, making them especially adept at handling the nuances and complexities of human language. Okay, that's interesting. Did not know that. The transformer architecture allows LLMs to pay selective attention to different parts of the input when making predictions. Since LLMs are capable of generating text, LLMs are often referred to as a form of generative artificial intelligence, often abbreviated as generative AI or Gen AI. As illustrated in Figure 1.1, AI encompasses the broader field of creating machines that can perform tasks requiring human-like intelligence, including understanding language, recognizing patterns, and making decisions. Includes subfields like machine learning and deep learning. Okay. So deep neural networks for parsing and generating human-like text. Machine learning with neural networks consisting of many layers, algorithms that learn rules automatically from data. Gen AI involves the use of deep neural networks to create new content. Okay, interesting. The algorithms used to implement AI are the focus of the field of machine learning. Specifically, machine learning involves the development of algorithms that can learn from and make predictions or decisions based on data without being explicitly programmed. Okay, so I did start down so on Free Code Camp's website, they have a machine learning curriculum, which I sort of started but then didn't ever come back to and finish. Yeah, I sort of started this and I haven't been back and finished it. But one of the things they talked about is basically what he's saying here is that machine learning is essentially it's essentially a different paradigm. So traditional programming looks like this. You have data plus rules equals output or result, right? I think something like that. Yeah, something like that. And then machine learning is more like data plus result equals rules, right? So you train it on large sets of data, and then you say yay, nay, yay, nay, yay, nay, yay, nay, to help the algorithm, to help the model figure out what is the right rules to get from input to result. And maybe that's a better, maybe output is a better input output. So it's completely inverts the whole idea behind building stuff. Okay, so instead of manually writing rules to identify, is everything okay, Ann? Huh? Well, you're just creeping around. To illustrate this, imagine a spam filter as a practical application of machine learning. Instead of manually writing rules to identify spam emails, a machine learning algorithm is fed examples of emails labeled as spam and legitimate emails. By minimizing the error in its predictions on the training data set, the model then learns to recognize patterns and characteristics indicative of spam, enabling it to classify new emails as either spam or not spam. Yeah, okay. So as illustrated in 1.1, deep learning is a subset of machine learning that focuses on utilizing neural networks with 3 or more layers to model complex patterns and abstractions in data. In contrast to deep learning, traditional machine learning requires manual feature extraction. This means that human experts need to identify and select the most relevant features for the models. Oh, okay, so machine learning requires manual feature extraction. Basically, a human needs to figure out what is relevant for the model. And this is so deep learning doesn't require this. Deep learning doesn't require this. That's kind of what he inferred, but he kind of said in contrast, okay? So while the field of AI is now dominated by machine learning and deep learning, it also includes other approaches. For example, using rule-based systems, genetic algorithms, expert systems, fuzzy logic, or symbolic reasoning. Okay, so here we go. So returning to the spam classification example, in traditional machine learning, human experts might manually extract features from email text, such as the frequency of certain trigger words, the number of exclamation marks, use of all uppercase words, or the presence of suspicious links. This data set, created based on these expert-defined features, would then be used to train the model. In contrast to traditional machine learning, deep learning does not require manual extraction. So deep learning does not require this. However, both traditional... So how does it work then? Do not need to... However, both traditional machine learning and deep learning for spam classification still require the collection of labels, such as spam or non-spam, which need to be gathered either by an expert or users. Oh, okay, so deep or machine learning require labeled data, but machine learning requires experts to specify specific features of the labeled data that the model would key on, I guess is the right word. Okay, so applications of LLMs. Owing to their advanced capabilities to parse, some of this stuff is kind of basic. Like obviously some of these things I probably could skip over, but I do want to try to do my best to actually go through this as I would if I was studying for like a class or a course or something. So owing to their advanced capabilities to parse and understand unstructured text data, I mean I paid $50 for the book, right? I better get my money's worth out of it. Today, LLMs are employed for machine translation, generation of novel text, yada yada yada. LLMs can also power sophisticated chatbots and virtual assistants. Moreover, LLMs can be used for effective knowledge retrieval from vast volumes of text in specialized areas such as medicine or law. This includes sifting through documents, summarizing lengthy passages, and answering technical questions. In short, LLMs are invaluable for automating almost any task that involves parsing and generating text. Their applications are virtually endless, and as we continue to innovate and explore new ways to use these models, it's clear that LLMs have the potential to redefine our relationship with technology, making it more conversational, intuitive, and accessible. We will focus on understanding how LLMs work from the ground up, coding an LLM that can generate text. We will also learn about techniques that allow LLMs to carry out queries ranging from answering questions to summarizing text, translating text into different languages, and more. In other words, you will learn how complex LLM assistants such as ChatGPT work by building one step by step, which I love. I love that this isn't just going to be a textbook, that we're actually going to get to actual building. Okay, so stages of building and using LLMs. Why should we build our own LLMs? Coding an LLM from the ground up is an excellent exercise to understand its mechanics and limitations. Also, it equips us with the required knowledge for pre-training or fine-tuning existing... Hey, Hunter. What's up, man? You're back, huh? Back at it. I'm doing a little studying. A little learning. What are you doing? Just hanging out? You're the only one here, huh? I haven't had very many people stop by and say hi, so I appreciate you stopping in. You're a man of few words, aren't you, Hunter? Sup? Yep. Not doing anything? Okay, cool. Well, fair enough. Decided to poke your head in. Yeah, I'm just kind of... I bought this book about a week ago, so I'm just kind of cracking it open for the first time. And my hope is that by the end of it, I'm going to have built myself my own little chat GPT. And hopefully I'll understand him a little better. Also, it equips us with the required knowledge for pre-training or fine-tuning existing open-source LLM architectures to our own domain-specific data or tasks. This actually is this. I have several ideas. Yeah, it is cool. Yeah, so we'll see. We'll see if I've got the brains to keep up. Most LLMs today are implemented using the PyTorch deep learning library, which is what we will use. Readers can find a more comprehensive introduction to PyTorch in Appendix A. I think there's actually a .NET implementation of PyTorch. Yeah, Torch Sharp. Torch Sharp no longer supports macOS on Intel hardware. And targeting .NET FX on Windows, blah, blah, blah. Okay. I'm going to bookmark this. I think I'm going to try to follow the code examples as best I can. Hunter, I bet you do. I appreciate your vote of confidence, man. Some of the words are already a little big. Let's see. What do they call it? Torch Sharp. Okay, we're back over here. Research has shown that when it comes to modeling performance, custom-built LLMs, those tailored to specific tasks or domains, can outperform general-purpose LLMs, which are designed for a wide array of applications. Examples of these include Bloomberg GPT. Oh, interesting. I didn't even know Bloomberg had a GPT. I do know what GPT stands for. It stands for generative pre-trained transformer, I think. Introduce. Oh wow, it's been out for a while. Oh, they have a paper too. Nice. I didn't know this existed. Bloomberg GPT. I know this is. I'm sure too. This is like thrilling streaming content, but I started streaming at like 8:40, and I was like, man, I do not want to crack anything open that's gonna keep me here till 2 a.m. So I was like, okay, let's just start with something chill, like some studying, and maybe some folks will show up and we can chat, and we just have a nice hour stream. Okay, using custom built LLMs offers several advantages, particularly regarding data privacy. For instance, companies may prefer not to share sensitive data. Yeah. Developing smaller custom LLMs enables deployment directly on customer devices. Yeah, that's what Apple. Yeah, Apple's trying to do that with Apple Intelligence. But I think, I don't know. That's funny. Yeah, yeah. Well, what was it? Tuesday night? I think it was Tuesday night. If you go to my channel, um, this happened to me. Actually, it was either Monday or Tuesday night. Let's see. 3 days ago. What would 3 days ago have been? Oh, today's Monday. What am I talking about? Today's Monday. So what's 3 days ago? Friday. 1, 2, 3. Friday. Yeah, I guess it was Friday night then. I sat down to work on something and it ended up being a 4 hour long stream. So I'm not looking to repeat that tonight. Let's see. This local implementation can significantly decrease latency, reduce server-related cost. Furthermore, custom LLMs grant developers complete autonomy, allowing them to control updates and modifications to the model as needed. Cool. I like that. Okay, the general process of creating an LLM includes pre-training and fine-tuning. The pre-training refers to the initial phase where a model like an LLM is trained on a large, diverse data set to develop a broad understanding of language. So I think that's a good definition we want. Pre-training refers to the initial phase where a model like an LLM is trained on a large, diverse data set. This pre-trained model then serves as a foundational resource that can be further refined through fine-tuning. So fine-tuning, what's this? Fine-tuning, a process where the model is specifically trained on a narrower data set that is more specific to a particular task or domains. The first step in creating an LLM is to train it on a large corpus of text data, sometimes referred to as raw text. Here, raw refers to the fact that this data is just regular text without any labeling information. Okay, so first step is training on raw text. It's raw because it has no labeling information. Readers with a background in machine learning may note that labeling information is typically required for traditional machine learning models and deep neural networks trained via the conventional supervised learning paradigm. However, this is not the case for pre-training stage of LLMs. In this phase, LLMs use self-supervised learning, where the model generates its own labels from the input data. Okay, that's important to know. So, LLMs use self-supervised learning. This contrasts traditional machine learning approaches that use supervised learning. I'll tell you what, there's been nothing super about all the supervisors I've had in my life. I don't know why they call it super. Let's see. Okay. Um, it's just a bad title. Like if you have the title supervisor, you know you have achieved middle management. Let's see. This first training stage of an LLM is also known. Watch, I'm gonna eat those words. I'm gonna get like promoted or something someday. You're now officially a supervisor, Steven. Someone will play this clip back to me. Hunter, oof. Yeah, I don't know, man. I just think something about supervisors that it's like someone gets that title and then all of a sudden they gotta justify why they have that title, and it's just painful, you know? Okay, the first training stage of an LLM is also known as pre-training. Yeah, you might like that, Hunter? That's funny. Yeah. I don't know. I mean, I'm sure you can relate. I'm sure other people can relate, right? Like you've had a bad supervisor. That's just, yeah. I'll tell you a story actually, if you guys want some little story time. So I had. Okay, so I was probably what was I? I was I probably hadn't turned 19 yet. I was graduated from high school. It was like it was like my first semester of college, and I was working at the local YMCA, and so far that job had been awesome. I had a really great boss. His name was Steven Binfield. Super awesome, just wonderful boss. Super guy. He was a super supervisor. Then he got a job, and he got a different job and left. And there was another fellow that worked there that got promoted. And I was doing personal training and like also being a weight room monitor. And I remember we had a staff meeting at like 3:00 one day, and I don't know why he scheduled it then, but he did. And so I sent him an email and said, "Hey, I've got a class at 2:00. It gets done at like 2:50. The campus where I was going to class and the gym where I worked was 15 minutes apart on a good day." And so I sent him an email and was like, "Hey, I've got class at 2, you know." And granted, it wasn't like we had a standing staff meeting, right? This was something new he put on the calendar. So I sent him a text. I sent him an email. I was like, "Hey, I'm probably gonna be late. I'm gonna do my best to get there as soon as I can, though." He emailed me back and was like, "Okay, I totally understand. No big deal." I get there at like 3:10 or something like that. I walk in, and it's me. It's like the whole department. The first thing he does is that when I walk in, he basically dresses me down in front of all these people about being tardy, and that, you know, if a meeting starts at 3, that means be here at 3. And I remember just kind of being like so embarrassed, like and mortified, because it was like I don't know, I was just super embarrassed. Like I just am not that type of person. I don't show up late to stuff. I turn in work on time. I follow through. And so it was like just he kind of was like blatantly calling me out in front of all the other people I work with. And I remember just kind of being like with my tail between my legs being like, don't you remember I emailed you I was going to be late? And then he was like, "Oh, yeah, I forgot." And that was it. And then he just like kept going with the meeting. Didn't say, "Sorry, I apologize for that. I shouldn't have scolded you in front of a room full of people." Yeah. To this day, I'll never forget that. I'll never forget how small that made me feel. And so I will never do that to anybody else, whether they tell me they're going to be late to something or not. You know, whether they try to head it off at the pass or not, which I felt like I did the right thing in that situation. You know, like don't wait to be late. Like let people know ahead of time. Like, hey, I have a conflict. I'll be there as soon as I can. That's Steven's story time. I've got more stories like that. I've just had some really bad bosses over the course of my career. I've had far more bad bosses than good ones. But that's also a good thing because I've learned a lot of what not to do as a boss or a leader. Um, right? So like I've kind of taken the positive from those experiences. Like I'm never gonna be like that. And it's also made me appreciate the good ones I've had, for sure. Hunter, yep. Yeah. I think you're Hunter. I think you're referring to my story, but um, yeah, I don't like this song. Okay, the first training stage of an LLM is known as pre-training, creating an initial pre-trained LLM, often called a base or foundational model. A typical example of such a model is the GPT-3 model. This model is capable of text completion, that is, finishing a half-written sentence provided by a user. It also has limited few-shot capabilities, which means it can learn to perform new tasks based on only a few examples instead of needing extensive training data. After obtaining a pre-trained LLM from training on large text data sets, where the LLM is trained to predict the next word in the text, we can further train the LLM on labeled data, also known as fine-tuning. So I'm catching, there's a little bit of repetition in this book, which I'm not sure I'm a fan of, but there seems like he's restating the same thing 3 or 4 times across 4 or 5 paragraphs. But I mean, that's kind of the nature of like kind of a textbook. Okay, so the 2 most popular categories of fine-tuning LLMs are instruction fine-tuning and classification fine-tuning. Okay. 2 most popular categories. See you, Hunter. I'll be back tomorrow. Hey, no worries, man. Thanks for sticking around. Thanks for coming and hanging out. I appreciate it. I hope you have a good rest of your day. I'll see you tomorrow. 2 most popular categories of fine-tuning LLMs are instruction fine-tuning and classification fine-tuning. And if anybody else is in the chat too, don't be afraid to send a message, because I'm definitely interacting with chat. So I'm not just gonna, if people are chatting with me, I'll respond. But otherwise, I'm gonna focus on studying. But I want you to feel like you can't distract me or interrupt me. That it won't bother me. Okay. After obtaining a pre-trained LLM, oh, I already read that. In instruction fine-tuning, the labeled data set consists of instruction and answer pairs. Excuse me. Instruction labeled data set consists of instruction and answer pairs. Classification fine-tuning. Labeled data set consists of text and associated class labels. Spam, not spam. Okay. We will cover code implementations for pre-training and fine-tuning LLM, and we will delve deeper into the specifics of both instruction and classification fine-tuning after pre-training a base LLM. Okay, cool. Yeah, I think it would be cool if I can understand in Grok how to do fine-tuning from this process. I think that would be very valuable, right? Because I could go and pull one of these open source models and niche it down to my specific application or use case, and basically be free, aside from whatever compute is needed for fine tuning, which I'm hoping is not much. That's actually a good question. So, because the compute for training the foundation models is pretty intense from what I understand. So, compute needed for let's see, compute needed for classification, no, for fine tuning. We will cover code implementation. I'm already there. Okay, this is going to be interesting. So, introducing the transformer architecture. Most modern LLMs rely on the transformer architecture, which is a deep neural network architecture introduced in the 27th paper. Attention is all you need. Okay, so I probably should read this. It's probably over my head, but I probably should make an attempt to read this. The paper that started it all. I'm guessing this is probably like required reading if you're in the machine learning AI world. Okay, so most modern LLMs, To understand LLMs, we must understand the original transformer, which was developed for machine translation, translating English text to German and French. A simplified version of the transformer architecture is depicted in Figure 1.4. The transformer architecture consists of two submodules, an encoder and a decoder. Okay, so let's start to build out this tree here. So a transformer has a encoder and a decoder. Let's see. Okay, so the encoder processes the input text and encodes it into a series of numerical representations or vectors that capture the contextual information of the input. Decoder. The decoder encodes, takes the vectors and generates output text. In translation tasks, for example, the encoder would encode the text from the source language into vectors, and the decoder would decode these vectors to generate text in the target language. Both the encoder and decoder consist of many layers connected by a so-called self-attention mechanism. So encoder and decoder are, what does it say? Or no, they consist of many layers connected by a so-called attention mechanism. The one question I do have is, like, what the fuck is a layer? What the fuck is a layer? That word has come up multiple times. I don't understand what it means. You may have many questions regarding how the inputs are pre-processed and encoded. These will be addressed in a step-by-step implementation in subsequent chapters. Okay, cool. A key component of transformers and LLMs is the self-attention mechanism, which allows the model to weigh the importance of different words or tokens in a sequence relative to each other. Yeah, that was important. They said that earlier. This was like the thing that allows LLMs to be better or different. Okay, the mechanism enables the model to capture long-range dependencies and contextual relationships within the input data, enhancing its ability to generate coherent, contextually relevant output. However, due to its complexity, we will defer explanation to Chapter 3, where we will discuss and implement it step by step. Okay, cool. Later variants of the transformer architecture, such as BERT, which is short for bidirectional encoder representations, and the various GPT models built on this concept to adapt this architecture for different tasks. So, okay, so we have the transformer, which gave rise to BERT and GPT. BERT is bidirectional encoder representations from transformers. And then GPT is generative pre-trained transformers, which I knew that one already. BERT, which is built upon the original Transformers encoder submodule, differs in its training approach from GPT. While GPT is designed for generative tasks, BERT and its variants specialize in masked word prediction. Where the model predicts masked or hidden words in a given sentence. This unique training strategy equips BERT with strengths in text classification tasks, including sentiment prediction and document categorization. As an application of its capabilities, as of this writing, X uses BERT to detect toxic content. Oh, interesting. Okay, so interesting. Okay, so BERT gets an input like this and then generates and then can fill it in. Whereas GPT gets a partial sentence or partial text and then completes it and generates one word at a time. Okay. That's interesting. I can see how the BERT approach could be more helpful for recognizing, because basically BERT can look both ways, right? It can, because the masked words can be in different parts of the sentence. That's kind of interesting, because it basically BERT can examine like a completed piece of text, whereas GPT is basically just saying, hey, give me an incomplete one, I'll give you the next word. And then I'm guessing it like recursively does that to figure out how to write an entire paragraph or page. Okay, so GPT, on the other hand, focuses on the decoder portion of the original transformer architecture and is designed for tasks that require generating text. This includes, GPT models primarily designed and trained to perform text completion tasks. Also show remarkable versatility in their capabilities. They can do zero-shot and few-shot learning tasks. Zero-shot learning refers to the ability to generalize to completely unseen tasks without any prior specific examples. Few-shot learning involves learning from a minimal number of examples the user provides as input. That's probably good definitions. So, zero-shot, no previous examples provided, in input for task user has given. Hey Kongzilla, how are you doing? My just ops pulled up. What do I do? Help me. What's my just OPS pulled up? I don't know what you mean, Kong Godzilla. So I'm not sure what to tell you to do. Oh, it's 9:30. This is probably a good stopping point. page 32. Section 1.5. Kong Godzilla. I wish I could help you, but it seems like you've gone away. I would love to be able to give you some advice, but I don't know what you're talking about. Okay, guys, I think that's going to do it for me. That puts me like right at an hour, which is what I said I was going to do. I have some other work I need to spend some time on, so doing a real long stream's just not in the cards for this evening. But if you stop by and hung out with me while I learned some things about LLMs, I appreciate it. I'm probably going to keep doing this for a little while. Probably not every stream, but there probably will be some streams where I just study. And if you find that fascinating and you want to talk and chat while I do it, great. If not, that's cool too. But yeah, this will probably be, I'll probably work this into my stream sometimes. Basically, when I stream, it's just me trying to make good use of that time to either create content or better myself or my knowledge. And then, of course, there's streams where I'm purely meaning to interact with you guys. So it's going to be kind of a smorgasbord of what we do when I stream. But if you stop by and say hi, like some of these guys did tonight, I appreciate it. Otherwise, I'm out of here. Hope you guys had a good Monday. Hope you had a good start to your week. We'll be starting Tuesday in just a few hours, so I hope yours gets off to a good start. All right, I'll talk to you guys later.